Welcome friends. Today we will discuss an important topic of operating system, that is deadlock. So what is a deadlock? A deadlock is defined as a situation where set of processes are blocked because each process holding a resource and waiting to acquire a resource held by another process. Okay, so please don't get confused between a deadlock and the starvation. Although both occur in the operating system, but they are different. See, deadlock is a situation where no process got blocked or no process proceeds. On the other hand, in the uh, starvation is just a situation where a low priority process got blocked and the high priority process proceeds. Okay, so there are four essential conditions for deadlock to occur. Deadlock can arise only if these four conditions hold simultaneously. Okay, these conditions are mutual exclusion, hold and wait, no preemption, and circular wait. So, what is mutual exclusion? Two or more resources are non-shareable. If there are two resources, or there are two or more resources which are not shareable between the processes, then the mutual exclusion will occur. Now, second condition is hold and wait. So, in this condition, a process is holding at least one resource and waiting for other necessary resources, and these resources are required for execution of this process, but these resources are required by some other processes. So this process can only wait for these essential resources. Now the third condition is no preemption. The third condition is no preemption. Now in this condition, a resource cannot be taken from a process by operating system forcefully. So the process can only release it by itself. OS cannot take it or preempt it forcefully. This is the third condition, known as no preemption. And the last and the fourth condition is known as circular wait. Now here in this condition, a set of processes are waiting for each other in a circular manner and wait for execution of each other. Okay, so these are the four essential conditions for. Now here we have some methods for handling the deadlock. The three important methods that we can discuss for handling the deadlocks are deadlock ignorance, deadlock prevention, and deadlock avoidance. So first of all, what is deadlock ignorance? Now deadlock ignorance is a method which is quite popular with Windows and Linux operating systems. So in this approach, the operating system assumes that deadlock never occurs. It means it simply ignores the deadlock. System ignores the deadlock because the performance of the system decreases if it uses the deadlock handling mechanisms like prevention or avoidance. Okay, although a deadlock is a very rare situation, so a system will let it happen, and if it occurs, it will reboot the system. Now, this approach is quite popular. The second approach we can follow is known as deadlock prevention. Now, the idea behind this approach is that uh, 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 the system will make sure that four necessary conditions will never arise. Okay, so if we can able to violate one of the four necessary conditions of this deadlock, uh, then we can prevent the deadlock. Okay, so what do you understand by prevention of a deadlock? Prevention is done by negating one of the necessary conditions for deadlock. Okay, so we can do prevention by using four different methods. Okay, so first of all, we will eliminate the mutual exclusion. This is the first condition of deadlock. So what we are doing here, you can use a spooling approach to avoid this condition. Okay. So basically we try to force a resource to be used by more than one process at the same time. If the resource is shareable, then we can simply eliminate the mutual exclusion condition. But it is not a practical solution. So we will see another solution, that is this is known as allow preemption. So deadlock arises due to the fact that processes can't be stopped once it starts. Okay, so in this approach, we take the resource away from the process, which is causing the deadlock. Then we can prevent the deadlock simply. Another approach we can follow is known as solve, hold and wait situation. Okay, so hold and wait condition lies when a process holds a resource and waiting for some another resource to complete its task. To avoid this, a process declares all the resources initially and then process must be assigned all the necessary resources before the execution starts. A process The last condition that we can violate is known as circular wait. To violate this circular wait, we can assign a priority number to each of the resource. A process can't request for a lesser priority resource. This ensures that not a single process can request a resource which is being utilized by some other process, and then no cycle will be formed. So after deadlock ignorance and after deadlock prevention, we can discuss the third technique which can be used for deadlock handling, that is known as deadlock avoidance. So avoidance is provided, basically avoidance provide a futuristic approach for solving the deadlock situations. In order to avoid the deadlocks, the process must tell the operating system the maximum number of resources a process can request to complete its execution in advance. The simplest and most useful approach states that the process should declare the maximum number of resources of each type it may ever need. The deadlock avoidance algorithm examines the resource allocations so that there can be never be a circular wait. Although deadlocks are rare conditions, but even if deadlock occurred, we can handle this by deadlock detection and recovery technique. Okay, so this technique basically consists of two phases. In first phase, we examine the state of the process and check whether there is a deadlock or not in the system. If we found any deadlock in the first phase, then we apply the algorithm for recovery of the deadlock. So this is all about deadlock. That will be all for today. Thank you for listening me. Good day.